All right, year 10. So today we're looking at factorizing by completing the square. Now this is a complex process with multiple steps. So to start off with, we're just going to look at what it means to complete the square. So to start off with, we are going to halve the coefficient of x. Coefficient of x in this case is 6. So the first thing we're going to do is say that 6 divided by 2 is equal to 3. Then we're going to square our answer to that. So 3 squared is equal to 9. We're going to add it and subtract it. So at this point, we're going to have x squared plus 6x plus 9 minus 9, and then we've got minus 2. Now, just to highlight it for you, in this step, we have added and subtracted 9. So by adding and subtracting it, we haven't changed the expression. Finally, we're going to complete the square. So x squared plus 6x plus 9 is equal to x plus 3 squared. Minus 9 minus 2, which when simplified gives us x plus 3 squared minus 11. Now you'll notice now that we have it in the form of a squared plus minus b squared. Okay, so later on we're going to be using DOPs, or difference of perfect squares, to factorize this further. But that's completing the square. It is getting from an expression to a form where we have a squared minus b squared. Example 1. So looking at example 1, we have x squared plus 4x plus 1. The first thing we're going to do is halve that coefficient of x. So 4 divided by 2 is 2. We're going to square it. 2 squared is 4. We're going to add and subtract it. So we are going to have x squared plus 4x plus 4 minus 4 plus 1. We complete the square. X squared plus 4x plus 4, which is x plus 2 squared, minus 4 plus 1. Collect our constants at the end. We have x plus 2 squared minus 3. Now, at this point, we have our a squared plus b squared. Just a quick recap. Well, sorry, a squared minus b squared. When you have a squared minus b squared, that can be written as a plus b, a minus b. And we know this from the quadratics that we did earlier in the semester. So what I'm going to do is use this rule to factorize the expression that I have now. So the square root of x plus 2 squared is just x plus 2. And the square root of 3 is root 3. So we're going to have x plus 2 plus root 3, x plus 2 minus root 3. Please check the description for the steps to go from here to here. Looking at example B, we have x squared minus 6x plus 7. First step, halve the coefficient of x. Minus 6 minus 6 on 2 is equal to negative 3. Negative 3 squared is equal to 9. We are going to add and subtract 9 to our equation. So we're going to have x squared minus 6x plus 9 minus 9. And then we bring down the plus 7. This will become x minus 3 squared plus 7. And if you are wondering where I get this number here from, I am always getting it from half the coefficient of x. If you look at example A, it was x plus 2 squared because we had a positive 2 as half the coefficient of x. Continuing on, we're going to use our dots. So the square root of x minus 3 squared is x minus 3. Then we're going to add the square root of 7. And our second term is x minus 3 minus the square root of 7. Moving on to C. In C, we have x squared plus 3x plus 1. So half the coefficient of x is 3 on 2, which we're going to leave as a fraction, as 3 on 2. When we square it as a fraction, giving us 9 on 4. We add and subtract it to our equation, so x squared plus 3x plus 9 on 4 minus 9 on 4 plus 1. That will give us x plus 3 on 2 squared. So x plus 3 on 2 all squared minus 9 on 4 plus 1. Now I'm going to rewrite that up here. So we have x plus 3 on 2 all squared minus 9 on 4 plus 1. I'm going to collect my end terms, so x plus 3 on 2 squared stays the same. Minus 9 on 4. I'm going to convert my 1 into quarters, so 4 on 4, which will give me x plus 3 on 2 squared minus 5 on 4. Now, at this point, we're going to apply dots. We're going to end up with x plus 3 on 2 minus, plus the square root of 5 on 4 x plus 3 on 2 minus the square root of 5 on 4. Now, from our surds, we know that we can rewrite the square root of 5 on 4 as the square root of 5 over the square root of 4, which is 2. And our final step here is to write everything over the same denominator. So we'll have x plus 3 plus root 5, all divided by 2. X plus 3 minus root 5, again, all divided by 2. This is part 1. Part 2 will be in the next video. Good luck.